So, really quick, today's a pretty quick lesson. I wanted to start by talking about something you'll need for the lab. So you'll see this diagram, right? We have solids, liquids, and gases. These are the stages of matter. The little circles in the containers are atoms, right? So solid things are rigid. They have a fixed shape and a fixed volume, right? You take something solid, you take it anywhere, it's going to be the same shape as long as you don't, actually physically break it. Solids do not boil. They melt, but they don't boil, right? They also don't they don't get any harder, right? You can freeze, you can make them as cold as you like, they still stay solid, they don't go to anything else. You'll see at the bottom it says cannot be squashed. That generally means that no matter how much you smash it, it's still going to be the same volume, right? You could theoretically take your pencil and break it down and break it and break it, but it would still take up the same volume. The atoms don't get any closer together, and that's what they mean by that. We go over to liquids. Well, liquids are not rigid, they have no fixed shape, but they have a fixed volume. They cannot be squashed, meaning that no matter how much pressure you put on a liquid, it still takes up the same amount of space, but let's keep in mind that, you pour a liquid into a different container, it's going to change its shape. The volume is going to be the same. We'll talk about what that means later. Liquid can go either way, right? You can freeze it, make it a solid. You can boil it, you can make it a gas. Interesting little thing about liquids. The fact that they have the same volume means that you can use them to do a lot of things that I'm sure you've heard of. I'm sure you've heard of hydraulics. That's the word I was looking for. Hydraulics, like you might see on a car that might make the car bounce up and down. That's really using water to move things, because water, if you push on it, it doesn't squish. So you can actually move things pretty well using water. Up next, we have gas. And, gas is air, right? They're not rigid. It fills any shape. It doesn't have a fixed shape, it has no fixed volume. Interestingly about gases is you can make the atoms in a gas, you can push them closer together. We will do something with that later, but before I forget, so you can't boil a gas, right? But you can condense it. You've seen that happen on the outside of a cold glass or water bottle, right? You see water vapor being pulled out of the air. So you can't freeze a gas either. You can only condense it down into a liquid, right? We don't jump state to state. That is something I need you to know for the lab that we will be doing on Wednesday. But today we're going to be talking about how we measure matter, right? We really only measure matter in very few ways. We will wind up measuring matter. You've seen us measuring matter. You're going to have to measure matter on the lab, so this is a skill we're going to get some practice in. We've talked about weight. I hope you know what weight is, right? Weight is the force that is generated on something by gravity, right? The stuff in you gets pulled down. We measure weight with a scale, right? And this weight changes depending on where you are. On Earth, Earth has a certain gravity. You have a certain weight. If you go to a different place, say the moon, that has less gravity, you will weigh less. It's like magic. Although you'll still be the same size. As soon as you come back to Earth, you'll be the same weight. Mass is something very different. Mass is the amount of stuff in an object. No matter where you go, your mass is the same. Mass is generally measured in kilograms. We've talked about this, right? When we did metric system. Your mass is constant. Scientists like to use mass because mass makes more sense, because you don't want a number about. If you are going to do science on something here and on Mars, you would like that number to be the same, and you would like to not have to do any math to figure out what that number is going to be. So mass is the amount of stuff that a thing has. So we talked about the International System of Units being, the metric system. We use this. We've talked about it. So there is another measurable volume of matter, amount of space that it is taking up. We can use cubic meters, cubic centimeters, liters, milliliters, depending on how we measure it. If we're going to measure it with a meter stick, we're going to use cubic meters or cubic centimeters. If we're going to measure it with some sort of graduated cylinder, which I'll show you all how to use, we will use liters and milliliters. All right, and here is our nice calculating. How do we calculate volume? Well, generally length times width times height. The area inside of it is the volume of it. You've done this in math. I won't ask you to do too much of this. But the reason that we talk about that is because density is an important thing. Why is density? What is density? How is it important? Well, density tells you how much stuff is in a given area, right? How much of that thing that you're looking at is in a certain area of a substance. Why does this matter? Well, sometimes things have different amounts of matter in the same area, and it helps to classify them. So the unit that we use to talk about this is crazy. It's grams per cubic centimeter, right? How much mass is in 1 cubic centimeter? You may also see it expressed as grams per milliliter, right? Because we talked about milliliters also being a measure. So all you do is you divide the mass of something that you find with a scale by the volume you find either using math or with a graduated cylinder. And we'll talk all about that later. Why is density important? Well, interestingly enough, all things have their own density based on what they are. And you can do fun things like this density tower over here. The denser things sink to the bottom, the less dense things float to the top. Why? The denser something is, essentially, the closer together the atoms are, and the more gravity will pull on it. Right? It can be used to try and figure out what something is that you don't know about. That's why it's useful. So, that is today's lesson. We covered 4 ideas and some states of matter for the lab. Now let's move into our activity.